Coordinates match nothing on record. Spectral readings spiking. Cyanide, carbon, copper, shifting every hour. The DoD has it under anomaly containment. Astronomers call it interstellar. No one calls it natural. If you're hearing this, stay tuned as we explore what NASA doesn't want you to know about 3I Atlas. By now you've heard the name, 3I Atlas. The interstellar wanderer that's dominated astronomy headlines since early July. But over the last 48 hours, its behavior has shifted in a way no one expected. On the night of October 29th, 2025, telescopes from Chile to Hawaii recorded a sudden surge in brightness. A magnitude jump so sharp, it triggered alert systems built to spot supernovae, not comets. For a world already obsessed with this passing visitor, the numbers lit up like static across the wires. A body born beneath another sun was flaring inside our own. It's no longer a question of what we found, it's how far it's willing to go. At roughly 1.36 astronomical units from the sun, the distance of Mars, 3I Atlas now moves through a maelstrom of solar violence. The far side of the sun is roaring with double-digit X-class flares. Magnetic fields twist. Plasma sheets collide, and through that storm, this object keeps brightening, as if drawing power from the chaos. Astronomers studying its light curves see a chemical fingerprint that doesn't fit. Carbon dioxide dominating over water ice by margins we've never seen in any local comet. The deeper they look, the stranger it appears. Volatile, reactive, alive in its own way. 3I Atlas is only the third interstellar object we've ever confirmed, but its behavior is rewriting every assumption we built from the first two. Some call it coincidence, others, communication. Either way, the data tell their own story, and tonight, we're following that story, tracing the evidence across space and solar fire to find out what this traveler from another star is really doing here. When the first detection alert hit the network on July 1st, 2025, astronomers already suspected what it was. The Atlas survey in the southern hemisphere had picked up a faint, fast-moving object skimming the outer edge of the solar system at nearly 60 kilometers per second. Too fast to belong here. Follow-up data from observatories in Hawaii, Arizona, and Spain confirmed it. The orbit was hyperbolic, an open curve, meaning whatever this thing is, it's not bound to the sun. It came from another star and will never return. In the following weeks, its trajectory took it inward through the plane of the planets, passing the orbit of Mars and heading toward the sun. By late August, it had grown a faint coma, a cloud of gas and dust, marking it as an active body, more comet than rock. Spectroscopic readings from the James Webb Space Telescope revealed something extraordinary. A dominance of carbon dioxide over water ice by nearly 8-to-1. A chemical imbalance never before recorded in any solar system comet. That composition alone told scientists this wasn't just a visitor. It was a messenger from a colder, stranger nursery somewhere beyond our galactic neighborhood. Through September, the European Space Agency's JUICE probe and NASA's Parker Solar Probe captured peripheral measurements as 3I Atlas closed the distance. The comet crossed its perihelion, its closest point to the sun, on October 29, 2025, at roughly 1.36 astronomical units. At that moment, the sun was roaring with one of the most violent flare cycles in decades. Coronal mass ejections blasted through the inner heliosphere while this interstellar traveler threaded right through the storm. For observers on Earth, the event played out like a slow-motion confrontation between stars, a relic of another system caught in the breath of ours. Astronomers across 5 continents watched as its light curve steepened again, each night brighter than the one before, its plasma tail rippling in solar wind like a flag against cosmic pressure. As the data poured in, one truth became impossible to ignore. 3I Atlas wasn't just passing through the solar system, it was reacting. To light, to heat, to magnetic fury, as though the space around it were speaking and it understood the language. Before 3I Atlas, interstellar visitors were theoretical, whispers of debris wandering between suns. That changed on October 19, 2017, when a cigar-shaped object named Oumuamua sliced through our inner solar system at nearly 90 kilometers per second. It showed no coma, no tail, yet it accelerated slightly as if pushed by invisible hands. That mystery divided astronomy. Was it natural or engineered? 2 years later, on August 30th, 2019, came 2I Borisov, discovered by amateur astronomer Gennady Borisov. This time there was no ambiguity. A textbook comet with a cyanide blue tail and the familiar vapor of water ice. It proved that fragments from other systems could look ordinary, even comforting. Then on July 1st, 2025, the Atlas telescope in Chile recorded a faint point of light racing through the outer system at 60 kilometers per second. Too fast to belong here. Follow-ups from Hawaii and Spain confirmed a hyperbolic trajectory, an object unbound to the sun, destined to leave forever. Within days, astronomers named it 3I Atlas, the third confirmed interstellar object, and the first tracked months before its closest pass. Early data set it apart immediately. At almost 4 astronomical units from the sun, it was already active, venting gas long before solar heat should have touched it. Spectra from the James Webb Space Telescope revealed something unheard of. Carbon dioxide outweighing water by nearly 8-to-1. That imbalance pointed headed to a birthplace colder and darker than anything near our sun. Perhaps the frozen rim of a red dwarf system. Oumuamua had been silent. Borisov, familiar. Atlas was something in between. A comet that behaved like neither. By the time it reached perihelion on October 29, 2025, Atlas had become more than another curiosity. A living experiment drifting through sunlight that wasn't its own. If Oumuamua was the question, and Borisov the reassurance, then Atlas is the response. The first visitor we could truly study before it vanished into the dark. Science lives for patterns and fears the moment they break. For 3i Atlas, that moment may be approaching as October draws to a close. After skimming past its predicted closest point to the sun on October 29th, astronomers are watching for what happens next. Early brightness models already show potential spikes that, if confirmed, could rival a small supernova in magnitude. The light curve appears to pulse rather than fade. The sun, meanwhile, is erupting. A far-side sunspot cluster, cataloged as AR3854, has begun producing powerful X-class flares. Plasma ejections racing at nearly 2,000 kilometers per second. And right through that turbulent region, 3i Atlas is expected to pass. It isn't the distance that unnerves researchers, it's the timing. If the largest flare coincides with Atlas's perihelion, we could see delicate plasma threads forming in its tail, dust filaments bending in near-perfect sync with the solar wind. Chemical readings from the ESA JUICE probe and the James Webb Space Telescope may soon show elevated carbon dioxide levels, possibly pushing the CO2 to H2O ratio close to 10-1, the highest ever observed in a comet. Should that occur, it would mean Atlas is heating from within rather than cooling after its solar pass. If these projections prove accurate, astronomers will label this moment the true shift, the point when Atlas stopped behaving like a routine object and started rewriting expectations in real time. As November begins, the tone around 3i Atlas is changing, from curiosity to caution. Instead of fading, it continues to intensify, its brightness still climbing, and its emissions shifting day by day. Comets aren't supposed to gain energy after leaving the sun, yet every instrument watching it shows signs of renewed activity. Each new light curve so far seems to echo the sun's flare rhythm almost in unison. If this correlation holds, Atlas could reveal something fundamental about electromagnetic feedback between interstellar material and solar plasma. One team suggests the comet's charged dust tail might act as a temporary electrical conduit, coupling with the sun's magnetic field like a moving filament in a plasma lamp. Others argue sunlight could be vaporizing carbon dioxide pockets beneath the surface, producing bursts that mimic resonance. No single theory fits all the data yet. Observers in Italy and Japan are preparing high-precision polarimetric measurements that could confirm whether its dust grains are crystalline and aligned by magnetic fields. If they detect that pattern, it would mark the first evidence of organized magnetic alignment in an interstellar comet. Whatever the outcome, scientists agree. Atlas isn't breaking physics. It's testing the edges of what we know. The revelation won't come from a single event, but from the ongoing attempt to watch those rules stretch in real time. If current forecasts are correct, the sun's flare cycle through mid-November, allowing 3i Atlas to begin its long climb outward. As it moves beyond roughly 1.5 astronomical units, scientists expect to see its brightness gradually stabilize. Teams at the European's Northern Observatory, NASA Goddard, and Japan's National Astronomical Observatory results. The emerging picture to carbon dioxide dominance and depleted water signatures, chemical traits that may trace to the frozen outskirts of a red dwarf system. At NASA and ESA headquarters, new observation windows are scheduled through December. The James Webb Telescope will keep watching, and the JUICE probe may capture additional plasma interactions along the comet's path. No official chase mission exists yet, but several rapid intercept concepts are being discussed. Outside those labs, the fascination is spreading. Amateur astronomers across forums are sharing stacked images and new spectral analyses. For a rare moment, the global skywatching community is united by a single moving point of light. Whether or not Atlas changes our models, it's already changed perspective, reminding us that our solar system is part of a larger galactic current still flowing through us. If present trends hold, 3i Atlas will likely fade from view by early December 2025. New imagery from late November should show the comet crossing beyond Jupiter's orbit, a faint blue smudge sliding back into interstellar space. Even after it disappears from our instruments, its legacy will remain in the data. The chemistry that challenged expectations, the light that defied prediction, the magnetism that may broaden our understanding of solar interaction. Scientists will continue debating what it means, but the larger lesson is already clear. Our solar system is not sealed, it breathes, exchanging matter with the greater galaxy and carrying fragments of other stars through its own airless tide. We once imagined visitors from other worlds arriving with signals and technology. Instead, they come as stones, mute, ancient, and patient, bearing messages written in chemistry rather than words. And still, we understand them. Somewhere tonight, beyond Mars, Beyond the frozen moons of Jupiter, 3i Atlas is still moving. No engines, no destination. Just a piece of another world passing through ours. This is Rick, reporting from Earth, still listening.